Okay, I have one more generator I want to show you. This is another hand crank generator. I turn the crank and you can't see it very well. But it's inside of this, here I'm going to put under the dot cam. Okay, here we go under the dot cam. So when I turn this crank, you can see that there's some gears in there that are turning, and the gears are ultimately turning this drive shaft here that goes into this gray cylinder. So inside this gray cylinder is where we have the coil and the magnet, and we're turning the magnet when we turn the crank. All right, so now I've connected the hand crank generator. This is just like the hand crank radio. The difference being that it has these two leads here coming out of it, so I can connect this to anything that I want to power with the hand crank. I'm not limited to just a weather radio or a flashlight. In this case, I'm going to connect it to this battery. All right, and I mean, not battery, this bulb. And I'm going to turn the crank, and as I do so, I get light. Okay, so I'm producing electricity that's lighting this light bulb. And a few things to notice: if I turn the crank slowly, I get a little bit of light. If I turn the crank fast, I get more light. Okay, so why does that make sense from the point of view of conservation of energy? Well, if I'm supplying a small amount of mechanical energy, I would only expect a small amount of electrical energy. But if I supply a large amount of mechanical energy, I would expect more electrical energy, conservation of energy. Okay, so I'd like to summarize electric motors and electric generators in a very general way, and that's in talking about their inputs and outputs. So a motor, if we think of it as a black box, we don't know what's going on inside. We don't know that there's a coil and a magnet or anything like that. All we know is the inputs and the outputs. What is the input to an electric motor? Well, the input is electrical energy. And that could come from a battery, for example. It could come from a wall outlet. And the output is mechanical energy. Motion, basically. How about a generator? The input to a generator is now mechanical energy, and the output is electrical energy. So notice that the motor and the generator are very similar devices. They just have their inputs and outputs flipped. Okay, so going back to my drawings of the electric motor and the electric generator, notice that they consist of the same components. They consist of a magnet and a coil, and that's pretty much it. In this case, we have a battery to provide the input. In this case, we don't have a battery to provide the input because the input's coming from over here. So you can see that a generator and a motor are built from the same components. Okay, so they're made of the same components, motors and generators. And I want to take that one step further, and I'm going to claim that an electric motor and an electric generator are actually the one and the same thing. The only difference is that they are operated in opposite directions. So if this is a motor, I put electrical energy in, I get mechanical energy out. If I then turn around and put mechanical energy in to the same device, my claim is that I'll get electrical energy out. That one device can act like both. All right? So, going back to this hand crank generator, think about this for a second. How could I test this claim using this hand crank generator? So initially, I was providing the mechanical energy, and I was receiving electrical energy. So I was using it as a generator. Now my claim is that this could also be a motor if I operated in reverse. So what should I do to test that claim? Well, what I'm going to do is, instead of using this bulb here, I'm going to connect it to a battery. Okay, so here we go. I have the hand crank generator, and I have it connected to a D battery. Okay, so let me reconnect that. This fell off. And I want you to watch what happens. What should happen if my claim is true? What should happen when I connect this battery? Let's find out. I'm trying to do this with two hands here. All right, so I'm gonna touch this lead to the battery, and the crank turns. Okay, so this device is now acting like an electric motor. I'm providing the electric input, and it's giving me a mechanical energy output. So one and the same device can be used as a motor or a generator, just depending on which order you operate it in. All right, one last example with this hand crank generator slash motor is now instead of connecting it to one battery, I am going to connect it to 2 batteries. So using conservation of energy, what do you expect is going to happen? So what have I done with the input to my electric motor? I've increased the amount of electrical energy that I'm providing to the electric motor. So what should happen to the amount of energy I get out of it? It should also increase if energy is conserved, which we know it is. So let's see what happens. All right, so it's moving faster now than it was before. Here's 1 battery. Here's 2 batteries. All right, so it makes sense from the point of view of conservation of energy. More energy input equals more energy output.